my contact details, email ID and mobile number. So if any questions comes in the presentation or demonstration, you can type in the chat box or you can contact me on this contact details. So first of all, today I will present the Ramcom software, which is a US-based company that provide a different simulation software for electromagnetic and wireless applications. So we will discuss about this wireless insight software for indoor, outdoor wireless propagation and MIMO and massive MIMO applications will be presented. So let me start. So audience, if having any questions, they can type in the chat box and I can answer after this presentation on the chat box as well. So Impulse Technology is based in Delhi. We are having, there are 4 partners for different applications we are working on. So my company is dealing on this kind of simulation software, wireless, 5G, MIMO, massive MIMO, and wireless communication, EMI, EMC, antenna, radar kind of simulation software. That is Ramcom, which is based in US, and we are the distributor for that. And Crosslight is a company for semiconductor TCAD device simulations, and this is for first principle DFT calculations and solar cell and OLED kind of simulations. So those who are interested in other software or their colleagues are interested in such type of software, we can have a presentation later on if they are interested. But today we will go for the demonstration on this Ramcom only. So let me continue. So basically Ramcom is a electromagnetic market leader with innovative simulations and wireless propagation tool. It was developed in 1994. Basically, it was developed for commercial and government contracting. It was developed for the US Army for urban propagation productions. Later on, it was extended for the rural productions, indoor propagations, outdoor propagations, and after some time, that capability was enhanced for different 5G, MIMO, then massive MIMO, beamforming, diversity, and all channel modeling kind of simulations can be done. It is based in State College, Pennsylvania, US, and developed in 2001 for specifically for wireless propagations in US Army. Now, what are the products from this Ramcom? Ramcom is a company name, and these are the product name from this Ramcom company. Now, those who are working on antenna simulations like microstrip antenna, pitch antenna, or some SCR calculations, specific absorption rate, waveguides, filter kind of applications, there is software called XFDTD. So for the antenna design, you can work on XFDTD. And for wireless insight, is a very good software for channel modeling, where it is a unique software for ray tracing applications, where users can easily predict the multipath of ray, like where you can predict that how much your signals is transmitting, receiving. So this wireless insight software is based on GTD and UTD method, geometrical theory of diffraction and uniform theory of diffraction ray tracing method, and FDTD methods. So using these ray tracing optics method, you can accurately predict the channel characteristics. And for a high frequency analysis, there is another software like if you want to simulate some complex structures like radars or some aeroplane you want to simulate. There is software called XGTD for high frequency analysis. This XGTD can work. For geometrical modeling and manipulations of human mass repositioning for medical or biomedical application, there is a product called Veripose and Redmond's lens design software for designing and synthesis of Rotman's lenses. So these are some products which I have given the overview, but we will go for wireless insight software for wireless propagations. Now, where we can use these software basically. These products can be used for antenna, microwave, cellular phone circuits, sensor networks, medical devices like MRI coils or pacemakers, jammers, where you want to block the signal, like on the stations. There is huge traffic. If that you are feeling that on that particular area, you want to block the signal due to some emergency. So that jammers can also be do the analysis here. So jammers, wireless and radio wave propagations. It can work for urban and indoor propagations, land, maritime and lateral environments. Broadcast the signals. You can increase the frequency of the signal and transmit the signal for the more frequency range. It can work for biomedical electromagnetic effects and EMI, EMC and electrostatic discharge kind of application for mobile dyes, or you can simulate a whole city. Like if you want to simulate a Chandigarh or Delhi or any specific regions in particular city, you want to simulate one street or one particular area. That map you can include with the software, and you can define the buildings and their foliage, trees, fonts, all these things you can specify, or you can import the 3D map data and you can define the transmitter and receivers and do the wireless propagation analysis. Now let me go to the more overview about this wireless insight. So basically, a main important thing is the propagation models. So first of all, I am just giving the presentation. After that, we will have a demonstration with a specific example of indoor propagation and MIMO application, massive MIMO. Okay. In the presentation, we will cover up what we can do inside this wireless inside. And after that, we will do how we can create a geometry or buildings or even a city, and how we can define the transmitter, receivers, their frequency range, antennas, waveforms, or channel modeling can be done. That will be specified. So basically, a main important is the propagation model, which can improve the analysis efficiency of your characteristics. So this software is originally developed for outdoor urban radio propagation predictions, then later on extended for irregular terrains. Like there is some hilly areas, some different terrains are there, where some hilly or some irregular structures are there, that is later on extended. In the beginning, it was for planar structure, but it extended for irregular shape. So foliage effects like trees are there and ponds are there. Then how the propagations or that signals distract by these effects. If you place the antenna inside the indoor scenario, or you want to place the antenna outside the buildings or outside the streets, then how the which at what location will be the better to use that antenna directions. So we can check that antenna direction, antenna locations, antenna height, all these things. Tracing method with GTD, UTD, different computer graphics techniques are there. It includes the 2D, full 3D vectors, fast 3D algorithms. X3D models are there which can run on the GPUs. Like some simulation takes a lot of time for the calculations. But this software support a graphical processing unit. Like in the computer, we normally use a CPU cores. But in the latest computers, we are getting a GPU card, which is having multiple cores that simulations can run multiple cores, which can improve the for the to complete the calculations. But GPU will decrease your speed calculation, time will be decreased. So using that ray models, it can work for 2D and 3D algorithm. You can evaluate the electrical fields and transmission coefficient. That can have different the material. So that also on the biology will be better and 2D models are there, urban full 3D ray tracing model with follow formal some frequency range, waveform limitations. So that's why there are a lot of propagation models are there which can work for this wireless propagation. One important thing is the graphical user interface. So how easy you can do the indoor modelings or outdoor modelings or MIMO applications. So this software is very good graphical user interface where you can import the city buildings, city structure in image format or TIFF format or Google Map data. If you are having your area Google Map data, you directly import inside the software and you can visualize in three-dimensional as well. Each city locations can be visualized. And after the importing of that particular street, if you want to change some height of some particular house, some particular building, height is updated, and if you want to modify, so there is a possibility to import and edit its geometrical features like if you want to change the height or you want to change the materials of particular buildings or foliage or terrain. So you can import and edit it. So this is a user defined possibility is there. Then you can specify the electromagnetic property of material like diffraction, thickness, or reflection, transmissions that you can specify. You can specify the location and properties of antenna, specify location of field points. You can specify the antenna direction or antenna point where you want to place the antenna on a big tall buildings or on the lower buildings. So you can analyze at what locations the antenna is good to fit, good to place. That we can analyze and we can check using the transmitter and receivers. If let's assume we are sending a 10 signals from the transmitter and receiver side, how much signals we are receiving, that you can do the analysis using the graphical user interface. We specify each and everything, frequency, waveforms, and also calculations parameter and desired outputs, what plots you want to plot, that you can specify and you can plot and view the results. Like this is the graphical user interface where city is imported and this is the desired output which we have specified and building hierarchical display are there. In the upcoming slide, you will get more details. So these are the feature data, like a city which composed of multiple buildings that can confirm by the terrains or unnecessary details like resulting the faster calculation. Terrain that can render itself, image projected, topographic maps or aerial photographs. Foliage are there, you can specify foliage, floor plans, you can insert the buildings or standalone floor, indoor scenario. You can also define the object like furnitures, vehicles, TVs or fridge, everything you can specify the locations. Now, geometrical and material properties. So using this wireless inside, like this is a wireless inside graphical user interface. Here these are some height of buildings, one floor, second floors. So where you can each colors you can specify by different materials. So that structure, substructure, faces can be specified. Geometrical data, geographic positions, electromagnetic materials, or you can display the properties. Material property of buildings, terrains, foliage. Like what property you can specify. Like you can define the reflection, transmission, and diffraction coefficient. Concrete, woods, metal, glass. So software is having own database. Material database base is already inbuilt with the software. I will show you. There are some metal, non-metal materials are there, glasses are there. So ITU International Telecommunication Units materials are there, which inbuilt with the software, or you can also create your own material and that you can use. And each phase you can assign the materials. New materials can be stored inside the library. User defined files with angles, frequency, polarization, coefficient that can also be used. So this is for the geometrical or material property calculation. Geometry you can specify and assign the materials with the geometry. Now these are the materials you can see in this graphical user interface. This is a graphical user interface picture where you can define the thickness, diffraction, coefficient, and all those things for the wood, metal, glasses. And each material is having unique color with distinguished, and you can assign with a different material. Like you can see wet earth, asphalts, concrete, dry fruit, glass. Like our house is there. The house, there are some windows are there, doors are there, and some wooden glass are there, and concretes are there. So everything can be specified. Ceilings are there, fans are there. So that buildings we can specify, and we can place the antenna outside the buildings or inside on the top of the building and check the analysis. So that indoor or outdoor propagation can be done. Like here, this is a urban ray path with signal strength. So here, wireless inside that can do the propagation model for full three-dimensional data. It accurately data for large number of cities. There is no such limitations of number of cities. Any number of image or city can be imported. Like you want to import a Delhi city or Delhi some particular area that you can also import here. So this is like a Delhi city where this like this is some place Rajiv Chowk place which we can import something like, and these are the specify of building sites, and we can place the antenna around the circle or any shape we can place. Different shapes are there for the antenna patterns. So if you don't want to create a city file, you directly want to import, that is also possibility. So AutoCAD DXF file format can be directly imported, and you can also edit it. So building data can be in different latitude or longitude, or UTM or Cartesian coordinates can be specified. Now foliage. So foliage is also important, which can extract the signals. So what foliage you can specify? User can create or edit it from the graphical user interface. Horizontal footprint can also be defined. Upper lower height you can also specify in each area. Vertically or horizontally, or effective permittivity, conductivity can be assigned in each area. Roughness parameter, transmitter, receivers, inside or outside foliage that you can specify it. And also you can see the node changes in the direction of ray path to the foliage is calculated. Like you can see, this is some green safe, this is some irregular safe. 1 kilometer land foliage is there, which is imported and created some particular heights. So these are some capabilities you can where you can specify the lateral wave or some canopy air interface. You can edit it or you can create or draw. Now, foliage area in urban environment. In the urban environment, like that foliage data consists of both land cover data and electromagnetic parameter library from different forest types. So this geo-reference foliage information can now be imported in GLCC format. So this is a foliage data information from this GLCC website that you can directly check and download that data and you can import. Like this is some city map foliage and that with the irregular terrain that you can import and do the calculations. Like terrain importation and terrain editors. So terrain can be imported from USGS, TED or DTS data files. That data files you can import and also change it. So user defined terrain importation or terrain variation can be described using editing tools. Like this is terrains, some hilly structures are there. This can be created with editors. Point can be moved or you can add the points at any locations. And terrain can also be defined like grading initially. Heights can automatically to be set to fit the terrains to lower edge of capabilities. And there is a comparison between wireless insight and this terrain software. That how much accurate our terrain is that. This is wireless insight and this is the terrain other software and how much we are getting more accurate analysis. The comparison between the results. Now transceivers. Let me check if there is any questions or not. So you can type your questions if you have any, so that I can after this presentation I can answer the questions. So now transceivers. So you can specify these transceivers are the point where radiations enter the scene, and receivers are a collection of field points where output from the calculation is obtained. So you can define this transmitter and receivers both. Both transmitter and receiver have associated antenna patterns and waveforms. So each transmitter and receivers we can associate antenna and waveform. This transmitter receivers provide different layout options. Like you can define this point can be defined independently, or you can connect this transmitter by the line segment or rectangular regions or by circle form, stairs form. Any type of shape transmitters can be defined. I will show you in the demonstration part. Now, in this wireless side, specifying the antenna. One minute. Now, specifying antenna property. Wireless inside is having many generic type antenna with variables. Like what type of antenna you can associate with the transmitter receivers and waveforms. So there is a linear dipole antenna, pyramidal horn type antenna, sinusoidal antenna, that page sinusoidal waveform, sorry, pitch antenna, helix, parabolic reflector, directional, bidirectional, or MIMO antenna can also be specified. You can import the NSA formats or Odyssey or MSI Planet format antenna you can import here. Like if you are working on some MIMO antenna in other software, so there is a capability like XFDD software for antenna simulation. and you can design the MIMO antenna in that, and that antenna you can import in this wireless inside software for further calculations. User-defined file for importing full 3D patterns, plot antenna patterns using the graphical user interface, plot of cuts, and it can also be imported the UAN file, antenna UAN file from XFDD, microstrip pitch antenna from XFDD antenna software that can also be imported. So this is antenna where you can specify like that. There you can define the transmitter and receivers on the top of the buildings, and you can check how much signals are receiving at the receiver ends. Now antenna. So this each transmitter and receiver in the projection are associated with the antenna. Antenna can be assigned and it can be imported in different format or you can create by yourself. Both possibilities are there. So antenna file can be added to the database or user can create custom antennas. As you can see in this graphical user interface, there is a functions called features, image, study areas, transmitter receivers, communication materials, antenna, waveform, output. Things can be done using the graphical user interface. Now, after antenna, you need to define the waveform because the antenna will be associated with the waveform. So this antenna will assign with the waveform. It contains the waveform database. This waveform such as frequency are used to determine the reflection, transmission, and coefficient, diffraction coefficient material. It supports waveform. Like what type of waveforms are there? Blackman and club waveforms, which Gaussian derivative, Hennings envelope, Rash cosine and root cosine waveform, sinusoidal, or user-defined waveform is also possible. I will show you the waveform frequency, latitudes, everything can be specified. A major important thing is the study area and communication analysis. In the study area, basically user allowed to specify regions in the project for which you can give a calculations model. In the study area, we will define the models. Now, what type of models can be specified? Like full 3D models, X 3D models, vertical plane, urban cannons, moving window, ATA, cost data, FDTD models, and some other models are there. These models, propagation models, will accurately predict the channel characteristics because some models is having some limitations of waveforms, some diffraction, transmission, some building height limitations. So that's why different model is having different properties which can work for different environment scenario. So these HATA, COSTATA or FTD models can work. User can study the geographic regions, propagation models, number of interaction, or advanced model parameters by the model specific. In this study areas, propagation models, retracing, number of reflection, transmission, or shooting bouncing ray methods are there. There is also possibility for the communication analysis where you can define the QPSK, PSK, FSK analysis. So this is a communication analysis where bit error rate, throughput toolbox are there. So bit error rate and throughput toolbox output can be created after the calculation by the communication systems. So if a system is active, then it will launch its post-processing automatically when the calculation is finished. So this communication analysis can also be done independently. It can assuming that output variables in the project current. I will show you the communication analysis window where Wi-Fi and throughput, bit error rates, QPSK, FSK analysis can also be done. Now, after creating the buildings or importing the buildings, defining the antenna, waveform, associate waveforms, transmitters, receivers, and propagation models. So after doing the modeling, now you need to run the calculations, simulations. Now the modeling part is finished. Now you need to run the simulations using the GTD UTD method. So user can run the specified to the whole project. If you want to run the new calculation or you want to change waveform materials before run the calculations, you can change the height. Like you can see this picture. This is showing you can add more transmitter, more receivers, change the height of that buildings, waveform, materials, or antenna. Or you can change the models or output. So this calculations can be run using GTD UTD ray tracing method. Ray tracing is very unique capability that may not be available in other third-party software. Now output. The output is generated based on the requested output tab. Now what output you basically desired that you can request in the output tab. So this output generated tab calculation can be viewed in the project window and plot for the detailed analysis. Propagation path calculation during the ray casting can also be viewed. Like here you can see this is the output tab where you can see the propagation path, received power, path loss, angle of arrival, delay spread, and MIMO, massive MIMO, CISO, single output analysis. We can visualize in the graphical user form or in the plot form. And these are some output where you can visualize in this picture form and plot form. So we have received power output from this transmitter. Like these are some area and these are some buildings and these are some signals which in the street. And this is a plot of received power from transmitter 15 to the point in the receiver routes. So this is the wireless insight for indoor propagations. Now let me show you. This is one building. In this building, now we want to place the antenna inside the same building. Where Ramcom office is space in State College. This is Ramcom office where the antenna is placed on the same building. So we can see how we can check the analysis. So, and in this form, the antenna is placed outside the building. So indoor propagation and outdoor propagations. So coverage from the indoor or outdoor analysis can be done like that. So you can see how much which antenna is better. Depend on the building site or building locations, we can check it is better for indoor or outdoor propagation. So this software for 3D vector state tracing models are there. There are very fast calculations. DXF, SAT, IGS file can be imported, specify ball material thickness, add window or doors, specify antenna characteristics, gain patterns, directions, transmitter, receiver location, floor plan you can also edit like that. We will create one floor plan. I will show it to you how easily you can create like one buildings inside the software. Now RF propagation with wireless inside. This can work for radio frequency propagation for commercial application. So rural, urban, indoor propagations. Like propagation over rough terrains, urban wireless communications, indoor, outdoor to indoor, indoor to outdoor communications. So this propagation can be done. Radar coverage, jamming. So either you can place the antenna inside the building or outside the building, and you can do such analysis. Now wireless inside moving window FDTD methods. So in this FDTD method, moving window FDTD method, high fidelity simulation of field over within of terrain can be specified. Like this is a object moving window FDTD concept. Like object in the sense like a vehicle, and vehicle is moving around the road. How it can distract the signal? If rain is happening or some cloud is happening, then how the signals are distracting the channel characteristics that we can specify using this software. So moving window FDTD methods is a longer range than typical 20 kilometers. Arbitrarily antenna patterns, urban canons models for time domain fields with urban environments. So this using this FDTD method you can check the moving object analysis. Now MIMO and massive MIMO. So basically MIMO stands for multiple input and multiple output analysis. So this MIMO technique is such a special multiplexing and pre-coding, which create a multiple streams to increase the data rate. It can use a beamforming to increase the SNRs. This technique requires various level of channel states information, CSI. Like this is a MIMO techniques which require channel states information, and let's describe about it. So in this pre-coding required channel states informing at both ends, at the transmitter ends and receiver ends. In this pre-coding, split the signal in multiple streams and use coding for beamforming. But for special multiplexing, we can use at the transmitter end, and it can split the signals. Transmitter transmit different streams for each antenna. It can work for channel characteristics uncorrelated. Can be combined with pre-codings if channel states information, and diversity techniques, which is not required channel states information. It takes advantage of various fading. So channel fading can also be specified for each antenna to pair diversity. So multiple, let me describe the advantage of this wireless insight. This wireless insight is provide efficient simulation of MIMO antenna with ability to model details antenna and channel characteristics. Like it deterministically predicts the variation of path across the MIMO array elements. You can define the MIMO array like 4 into 4, 8 cross 8 array of antenna can be specified. And you can use to virtual assessment of systems scenario perform in complex environments. Wireless Insights offer tools for research and development, virtual testing, evaluation of concept. It can enabling 5G research for MIMO simulations. So MIMO and MIMO are a key concept for 5G technology. Wireless Insight supports for 5G, MIMO, massive MIMO applications, channel modeling, beamforming, diversity. This Wireless Insight MIMO capability provide efficient method to predict the channel characteristics for large array MIMO antenna in complex multipath environment. It provide very unique key benefits like provide capability to perform the R&D assessments and enable virtual testing. MIMO is basically massive MIMO is basically an extension of MIMO. Now let me discuss about massive MIMO. Massive MIMO, multiple input, multiple output, the extension of MIMO, which essentially group together with different antenna and transmitters and receiver ends to provide the better throughput and better spectrum efficiency. This Rancom wireless insight provide efficient method to predict the channel characteristics for large MIMO array antenna in complex multipath environment. You can draw 4 is to pro 8 is to 8 or 16 is to 16, 16 cross 16, 8 cross 8, 4 cross 4 array of antenna. So with this 5G The industry is targeting to ability to connect 10 to 100 times more devices. Like if you want to connect more than 100 devices on the same antenna. So using this kind of software, you can predict channel characteristics with higher data rates can be increased using this massive MIMO capability. It can increase the overall capacity of the channel characteristics. So this method basically ability to multiply the capacity of antennas, like it can work for different wireless standards, 802.11 and Wi-Fi or WiMAX LTE kind of applications. So let me show some examples of this MIMO antenna and massive MIMO antenna also in this demonstration part. This is just only presentation. These are the current customers which are using this wireless insight software for wireless propagation, wireless kind of application, MIMO and massive MIMO antenna. IIT Delhi, NITTTR Chandigarh, SRM University, NIT Kurukshetra, and IIC Bangalore and IIT Kharagpur. They are our already existing customer for wireless insight only. There are some other customer of Remcom also for antenna app applications. So we are here as a distributor for this software in India. These are my contact details. So you can note down my contact information for that. And within 5 minutes, I will start the demonstration on indoor propagation, and we'll go for MIMO and massive MIMO application. So you can, if you want somebody want to note down my information, they can note down these details. And in future, if they require some published papers, manuals, brochures, or some videos link, that we can also share. If they need some presentation, this presentation we can also share with you after the demonstration. So thank you for your patience. Let me go to the demonstration part. You can type your questions on the chat box and I can read and answer. Let me show you this website. You can type ramcom.com. Ramcom is a company name which is based in US. This provide a wireless and electromagnetic simulation software. So here you can see these are some product updated and wireless inside. I was representing this software. We are having other product like GTD for high frequency, Waveforms for radar simulation, antenna simulation, and applications.
Excuse me, sir.
RGMIMO. Yes.
Sir, your screen is not visible.
Can you repeat your questions? I did not understand.
Sir, the screen is not visible.
The screen is not visible?
No, sir. Garima ma'am, is it visible to you?
Oh, one minute, ma'am, please.
No, अनिल जी आपकी स्क्रीन दिखाई दे रही है क्या? आई थिंक
Okay, one minute.
नेटवर्क इशू क्योंकि वॉइस भी बीच बीच में ब्रेक हो रही है.
Yes, ma'am.
Oh, maybe.
Okay.
Let me check my screen. Now is this visible? This Ramcom wireless inside this electromagnetic simulation software.
Yes, sir.
Okay. So this is a company Ramcom.
Yeah, it is visible now.
Great. So now here you can see, you can type on the Google and find more information about this software. You can see electromagnetic. Now these are product. We were discussing about this wireless inside product. If you want to inquire more details about other product, you can check from these website. And these are applications. 5G MIMO, and some wireless kind of application, wireless propagation. So there are some published papers, tutorials, videos, or some project file already inbuilt with the software. In this website, you can find more information like that 5G, microcell, 5G noise, LTE, WiMAX throughput, indoor Wi-Fi propagations. Some videos is also there for the channel modeling. You can get more information from here. Like millimeter wave channel modeling, you can type, click and get more information. Like this is 5G MIMO outdoor communication analysis. You can request project file for this example. Like here, their area of builders are defined. So every steps is specified properly in this website. So now let me go to the demonstration part. Now this wireless inside window is visible.
Uh, no, Anilji.
Uh, One minute.
No, sir.
Yes, sir, it is visible now.
Now is it visible? Okay, perfect. So let me demonstrate this how you can do the indoor modeling, indoor propagation and outdoor propagation, and MIMO interface where there are two windows. There are two windows in the software, main window and this is a project window. In the main window, you can specify image, features, materials, waveform, antenna, transmitter, receivers. As I explained in the presentation, that is all things are there. This is there is health section where reference manual and user guides. So for those who need the reference manual and user guide, I can share with you after this PPT. I have uploaded on the Google Drive. I can share and you can find more information on the manuals. In the manuals, indoor propagation and MIMO manuals is already there. So apart from that, there is an option called project. If you want to create a new project, there is option called project. Then you can go to the new. This is new features. Feature in the sense you can create a city, terrain, foliage, floor plan, transmitters in different shapes, arc shapes, cylindrical, polygons, root, spheres, whatever shape you want to create, that you can specify. And this is a receiver set, what kind of receiver you want to specify. There is a possibility to specify the receiver. Trans receivers, these are trans receivers, antenna patterns. So you can click each and every, you can click each and every options and specify the antenna or some material property. Let me go. This is for you. If you want to open an existing project, there is a open called existing project or open existing city file. Like if you want to load a city, okay, you can directly open the city file. Click on city this city file can be imported. Floor plan can be imported. The import section, and these are the file format which you can directly import inside this wireless set software. Followed are DXF, EMZ, SAFE file, STL file format, terrain file format, this or transmitter receiver file that you can import directly. These are project statics where you can define the latitude, longitudes. Now let me take one example of indoor propagations. So can you visualize this my wireless insight tutorial user guide, 3D wireless communication and propagation
Yeah, it
protection?
is visible.
Okay,
Yes.
perfect. Perfect. So this is a user guide where user can perform the different assignments. Experiment can be performed this. Now you can see simple irregular terrain indoor tutorials, outdoor urban propagation protection tutorials, co-setting of WiMAX transmitters, maximum permissible exposure protections, modeling parameter using Monte Carlo, cost, building penetration model, and MIMO tutorial. These tutorials we can perform. Now let me go to the indoor tutorials. Chapter 3 Indoor Tutorials. So this tutorial basically explores some feature of wireless insight for making indoor propagation. Now, like this is some building. This is some building where some elevators, classrooms, and house is there. In that window, doors, and some different material structures are there that we can simulate using this wireless insight. So there are two ways. Either we can load the floor plan directly inside this software, or you can create the floor plan. Let me import the floor plan. I go to the file project and click on open and create the city file. If you want to create a new city, go to the project and create city. This is a main floor plan window where you can create a city like that. You can draw new building. There is an option called new building. Click on each point to define the area. And this is a building. Now this is our house. Okay. If you want to create one house or you want to create one street, that is also possible. In this, this is the outer boundary of our house, and we can specify base height and top height. You can manually set whatever you want. This area we have specified. And after that, if you want to specify some roof material, like this is a roof material is using as a concrete or ball material, you can also define. You can replace the material or change the material. Okay. This is for entire boundary condition. And you can specify the, like this is a city. If you want to define the coordinate systems or longitude, latitude based or Cartesian based, Euclidean based, that you can also specify as longitude, latitude, or Cartesian forms, decimal, degree, minute, seconds form, and click on OK. And that you can visualize in this project window. So this is project window, 3G project window. Now we have created this one in the floor plan. So this is our outer boundary, and in that, if you want to create city, after that you want to create some terrain or some floor plan, that you can also specify in that particular region. Like here you can define the wall, doorway, ceilings, everything can be specified in this window. Now this is your outer boundary, and if you want to create a doorway, to enter the width of the doorway, this is door. You can place a door here, one door this side, and define the materials. Layer dry walls. You can define the thickness or free space. Like one door is placed here, and you can place the next doorway. There are two doorways are here. You can place second doorway in this region. You can change the top or bottom height as well. And if you want to place a window or floor plan or ceiling, this is a window where you can place the window. Let's assume this side. This is window. You can specify in this plate plan, and you can change the materials or replace the material from this region. There you can define the thickness, roughness, conductivity, permittivity. As I explained in the presentation, that material property can be changed. So manually you can change this property. Then click on OK, and then click on OK. Now we have specified this is whole city. We can something like we can define. Let me remove this one. This feature is automatically included in this region city and terrain. You can delete this one like this one. So we have placed two doors. We can move this one as well like this. There are doors and one window backside. So this was our floor plan. We can also edit it. You can change its position. If you want to edit that floor plan, you can edit. And if you want to draw one more layer or some wall inside that, you can also define. So for the indoor modeling, this is 3D map data where you can visualize like that. So if you want to create one building or even city can also be created. And if you want to select any particular structure or substructure like that, or face you want to face particular face you want to select, like this is selected face, and in that face you want to change the material. This is change material structure. Choose a different material from this window. This is material directory. ITU ceiling board material with different frequency. Multi-base materials are there. Like this is changed. Like that. So this is just an example that how you can create such a floor plan inside this software. Now let me open one existing floor plan. One minute. So let me load the floor plan. So because the complexity of the floor plan in this example, we will import from our library. Okay. So let me go to the project and open features and floor plan. So from the example, this is example directory under C drive program files, RAM-COM file is inside, and tutorials. These are tutorials, indoor tutorials. Indoor floor plan object is there, which I can import. So I imported this floor plan structure. You can see where we have having this house with this gallery, some doors, and different colors is also assigned. Okay, so this is a floor plan which we can create from the floor plan object, as I explained in this beginning. Okay, such type of floor plan we can create inside the software or directly we can import. Okay. So after importing this feature floor plan, there is an option called image. If you want to import some image, there is an option called import the file, image file. Image file can be imported. You import an image. So this TIFF file, JPG file, JPJ file, that data can be directly imported so that you have no need to create, or you can create. These are two floor plan and these are longitude and latitude directions. Now after creating this floor plan, you have to create the material. So material is already assigned. Okay. Material is already assigned there, and we can visualize that which material is having property. This is a property of layer dry wall, permittivity, conductivity, and thickness. If you want to define more materials, you can click on new and define the material section. And choose the material floor plan. For which floor plan you want to choose the material. So this is create a new material, or you can import the user defined file. So constant coefficient, dielectric half space, free space, layer dielectric, perfect electric conductor, perfect electric conductor back layer, user defined Monte Carlo multi-material variable of single parameters, that you can create a new material here. And the new material you need to define either it is dielectric or metallic or free space, that you need to specify the thickness, roughness, conductivity, permittivity, color, and you can also plot its characteristics. That material data you can plot. Material data you can plot the magnitude with the angle. This. If you want to perform diffuse scattering, so this is diffuse scattering. Scattering is basically for complex paths, for different complex structures, for dense environment. This is scattering models can work. So these are different scattering models, Lambert-Eaton, directive with back scatter. So you can also define the diffuse scattering, enable the material diffuse scattering. So either you can create the new materials from here, click on new, create the material. Okay. The material is created here. Now let me delete some, let me create a waveform, antenna, transmitter, receivers, study area, and output. These things we will create here. Once you create this floor plan, the material will automatically assign, or you can define your own material, what material you want to choose. There are two floor plans. In this main window, we can visualize these floor plans. Okay. Now, main important thing is material. Material is already assigned. So, what materials we are using? 3-layer dielectric, free space, 1-layer dielectric, half space, bricks, thin bricks, medium bricks, wood, thin concrete. These material metals, floor plan, ceiling, perfect absorbers. These things we are using. And on the bottom side, you can see the material library. Material library is available inside this project directory. A huge list of material library, different frequency range. All ITU standard materials are there. 3-layer dielectric half space, 1-layer, and biophysicals material is also there for dense deciduous forest, or sparse forest, sea waters, asphalt, dry earth, dry sands, glass, ceiling, concrete with different frequency range that you can check. Medium, bed, earth, like that. Whatever material you want to use, you can pick up from the material directory. Like if you want to replace, you can click and click on replace. And from this directory, you can choose. Like you want to replace this material and select from this material and click OK. It will automatically replace like that. So now main important thing is we need to define the waveform. To define antenna in waveform, first of all, we will create a 900 megahertz sinusoidal waveform. So how we will create it? Create a new and click on waveform. This waveform, and there is options: Blackman, chirp, Gaussian derivative, Hamming, Henning, hash, cushion. Anyone you can define. There is user defined possibility is also there. So let me define the sinusoidal waveform. Click on OK. Here we need to define the sinusoidal with 900 megahertz. 900 megahertz waveform. Here we can specify 900 megahertz. And here we can check its waveform plot. This is a waveform plot with amplitude, with frequency, and with respect to the time. Okay. Monte Carlo, if you want to do active Monte Carlo for carrier frequency also. Now click apply and OK. Now it is defined. 1 minute. Let me. So effective bandwidth 1, carrier frequency 900 megahertz, and phase value is set to 0. Now we click OK. Now there is waveform in the project. Waveform is associated here, you can see, but it is not in use. Until we don't define the antenna, it will not be used. Now go to the antenna tab, click this and go to the new. You can define the linearly dipole antenna. Now this is antenna, half wave dipole, helicals, horn, isotropic, linearly dipole, linearly monopole, MIMO. Now MIMO is also there, MIMO antenna, Odyssey format, omnidirectional, parabolic reflector, planet, wave monopole, rectangular aperture, rectangular pitch antenna or short dipole. So let's define linear dipole antenna with vertically polarized. So linear dipole, vertical linear dipole, and here we can specify length of that antenna. Let's assume this, and this is receiver threshold, and the VSWR and temperature. VSWR effect. And now I click on OK. So this is defined vertically dipole antenna, and now waveform is activated. It is in use. Now after this antenna, we need to create the transmitter and receiver point. So this is transmitter and receivers. Uh, Now we are now ready to place the transmitter and receiver points at the locations of floor plan. So to create the transmitter, I click on right click and transmitter set. And we can define the point tag transmitter. Click. Now this is our transmitter point. In this project window, we need to specify where you want to place your transmitter. You need to fix your transmitter at good place location. So click on project, view transmitter point and specify. Let's assume I specify on this region. This is my region where I place the transmitter and right click. So transmitter receiver properties, like transmitter TX with height equal to 1.3 meter. We can define originated points You can specify from here location or from there. From sea level, let's assume from sea level, we can define the elevations and also click on the transmitter properties. This is the transmitter property where this is vertically linear dipole antenna with waveform is associated. Now this is transmitter properties and input power. We can define the input power, calibrated received input power. We can specify like 27 something. We can specify, then click on OK for the transmitter property. Now click on apply and click on OK. We can also define the layout property as well. One minute. Transmitter receiver layout property. We can set this layout property and click on OK. And then we can click on OK. Like that. Now this is height, the transmitter is set. Now if you want to create additional transmitter, one more transmitter, let's assume we need to again click on transmitter tab. Now one transmitter point is added. Okay. Now if you want to define more transmitter, click on new and transmitter sets. Any shape you can specify at different location. Like at this location you want to add. Right click, transmitter with 1.6 meter height. You can specify. And from sea level, you can also define the transmitter property in this input power. Similar. Apply, then click on OK. Now two transmitter sets. Now if you want to define the receivers, the two transmitter is activated. So antenna is already in use, waveform is in use, and receiver set we need to specify. We can define the route of receivers for particular locations. Like these are different route of receivers. Receiver route. Antenna waveform is associated. And click OK. Apply and then click OK. Now you can see this red dotted line called is receiver routes. This is RX route written and two antennas are there, 1.3 and 1.6. Now we need to define the study area. So till now we have done the feature modelings, like floor plan is added. We can create or import material. We can assign to each or specific boundaries. We can create the waveforms. Waveform can be created and assign the antenna. Antenna is assigned transmitter and receiver sets. We have created a study area. Now study area, click on new and go to the study area. You can specify location or size or filter features. Now study area is major important thing. Study. Propagation model, we can specify propagation model. Now these are the propagation models. Now as I discussed in the presentation, these are some models for 3D model. For different models, different algorithm are there. We have one summary of propagation model, that which model can work in which environment and what are the limitations of full 3D models, what are the limitations of X3D models, that already explained in the manuals and user guides. Let me assume full 3D model. You can define the ray spacing, number of reflection, transmission, diffraction, shooting and bouncing ray method or energy method. And this is X3D models. In this X3D model, some foliage models you can define with different units, and diffuse scattering you can enable in this X3D. So this X3D model can work for MIMO applications. Carbon cannon models are there, ray spacing, vertical planes models are there, linearization terrain, effective earth radius, post Hata models, free space models. These all are free space models. So empirical deterministic free space propagation models are inbuilt with wireless inside. So you can use any propagation model in different scenarios. So let's use full 3D model and use default properties. These are all automatically enabled calculations. I click on OK. This propagation model is there with full 3D shooting and bouncing ray method. And this tab stands for communication system, for communication, massive MIMO communication analysis. So in this communication, you can see what type of communication you can do. So this communication system property tab describe basically analysis of bit error rate and throughput. Bit error rate and throughput, and interference and receiver summarize refile. So here you can see you can all transmitter or receiver set. You can select and define the bit error rate, throughput, and this is throughput options. This is MIMO option. When you will use the MIMO method, this MIMO method is there for beam forming, diversity, transistor beam forming, pre-coding, closed loop, spatial multiplexing. So wireless access method is there, LTE, WiMAX, and 802.11 AC, and with NTAP or user-defined throughput options. This is for wireless throughput communications. You can set the communication analysis. In the bit error rate, you can, this is the option for bit error rate options, where you can define the signal bandwidth modulation scheme. As I explained, some PAM, QPSK, FSK, DPSK, MSK. These are the communication systems bit error rates options. And these are the bit error rate method: adaptive wide Gaussian, theoretical fading, semi-analytical fading, kind of propagation analysis, interference and summary analysis, the signal parameter only. This is for communication system tab. Throughput and bit rate calculations can be done. Now I close it. Now next is output. In the output section, you can click and select desired output. Barbara. So let me explain in this tutorial what we have done till now. So we have loaded the floor plan like that. So after loading this floor plan, we have defined the antenna and waveform. So 900 megahertz sinusoidal waveform antenna were defined. This is the antenna properties. Linearly dipole antenna and waveform. Waveform antenna were defined. After that, we created the transmitter and receiver routes. So as you can see, these are two transmitters. One is this side, and second is this side. And this is a route of receivers. Okay. Now we will analyze this, that why this transmitter is it able to just transmit the signal through this wall, that we can see this ray optics method. We are now ready to place the transmitter receiver. Transmitter and receiver are already settled down. So with two transmitter and two receivers that we have already specified as given in this picture. Our study area, we discuss about study area. In that we have defined the models. Which model will provide a more accurate? Like full 3D models are there. So using this full 3D models, now main thing is that simulations. We start the simulation. This is option. This is option we are showing in this red color to run the calculation. Click on this and click on new. Click on a yes, and you need to save the project. Now this is the calculation window, which is showing that the simulation is started. This one is calculation window, which is showing that calculation is running, where how many creating the transmitter, receivers, diffractions, all these things is specified. Now after finishing the calculations, we can analyze the results. Calculation is running. It will take 2 minutes or 5 minutes time maximum by. But in the meantime, let me explain these results from the tutorial. Now 10% is completed. So let it run the calculation in the background. In the meantime, let me show you some running the calculation results. The tutorial. So these are some comparison analysis with the imported product and transmitter height 1.3 nanometers. These are the results which we are getting results. So this is a received power comparison of wireless inside calculation to measurement for receiver routes with transmitter height of 1.3. And this is different receiver route to receiver route A and B. There are two receiver sets are defined in that. Compared with this dotted and green dotted and red graphs are there. So this is a comparison between. Since theory is based on the predictions, so 95, 98, 96%, we can get the accurate results. This is a comparison. This is for 1.96 meter height transmitter. Imported data and simulated data. Now viewing the ray tracing data. This is a ray tracing. This is ray tracing data. So in this, like these are transmitter. Now here you can see the signals are transmitting and receiving. Some signals are able to transmit this ball and some are not able to transmit it. As you can see, these are some signals putting in this ball and reflecting back, then reflecting like that. And this green signals, because of this material of this ball with different color, it's described that it is able to transmit through this ball as well. But this signal, blue signal, is not able to transmit from this ball. It is refracting, and this is transmitting through the ball. So these things we can analyze inside this software. We can also see the receive power, high plane, like that.
Anuji, we need. Hello.
Yes, ma'am. Tell me.
We need to.
Hello.
Hello.
Yeah, ma'am. Tell me.
Yeah. If you can sum up this session because we have to continue with the second session after 5 minutes break. So if you can.
So
And
I
if
when
there is
I
any query, uh, till simulations are running, we can take the queries from the participants.
yes.
Yeah. If there is any query, please write in chat box to panelist so sir can easily see your query. Otherwise, I want to ask as
Ma'am, your voice is breaking. Can you please type in the chat box?
there is echo.
One
Hello,
minute.
Nina.
Yes, ma'am. Tell me.
Is it clear now? I'm. Is it clear?
Yes.
Yeah. So I want to ask one thing that as you are running these propagation models, either indoor or outdoor propagation models, so they are having some inbuilt or defined propagation models, Okumura, Haka, and on. So can we include these models such as we are running for now new communication technologies? So we need to define new models also, channel models also. So, is it new models already available? Some new models, or we can run our own algorithms and then we can implement those algorithms in this software. Or
You want to
interfacing with
define,
this software.
sorry, what did you say?
You just answer first.
Yeah, definitely. Basically, there are already inbuilt models which is majorly used for the project propagations. And in these models, you can specify different parameters. And if you want to define own models, own algorithm, that you need to write in the script in the database. But directly, there is no such options where you can define your own model because it is a developer's only because the codes are proprietary. So whatever models are there, only in that models you can change the material parameters. But major important models which required for the propagation is inbuilt with the software. Okumara, Hata, Costrata, 3D.
So we can, yeah, these are the basic defined models in wireless propagation, but they have some limited frequency ranges, some limitations also. For new frequency bands and for upcoming frequency bands, we need some new propagation models. So is it there any interfacing of any other software, for example, MATLAB? If we create some algorithm in MATLAB and we want to basically interface MATLAB with this particular software, so can we call our algorithms from MATLAB to this software, propagation algorithm, suppose, so that we can have the information regarding the propagation performance of that model, basically?
The model basically algorithm, I don't have idea that models can be imported or not. But user defined antenna, waveform, materials, transmitter receivers, these things you can directly import. That user defined is possible. But as talk about propagation models, I don't think that is available to import.
Oh,
Either only the geometry or SETI files or materials waveform antenna, but not propagation model.
so if we are calling some user-defined models from, obviously we are taking it from some other software or some other medium, then maybe there will be option of interfacing of this particular software with any other software. Because many of the research-based softwares, they give support for any open source software combination or for commercialized software. And specifically this MATLAB, because many of the people who are working in research areas, they're mostly using MATLAB, and so they are interfacing MATLAB algorithms with many other softwares.
So
So,
let me tell you. The
yeah,
calculation is finished. It is showing the pop-up
yeah.
calculation. So here there is an option called import. You can see import. So standard file format can directly import it. Like DXF is a very good standard, most important file format for CAD. So that is like CAD format, CATIA or some other commercial software. CATIA kind of application where DXF files are there. STL file, that is also a very standard file format. Even Google map data can also be imported. But for MATLAB interactions, I don't have a full idea about that. But these most important file format is directly supported. But I
Okay,
can
okay.
confirm after discussion with my principal.
No problem.
Yeah. So now the calculation is finished. It is going in this region. So in this region, where basically we can analyze the propagation model, like delay spread, path loss, path gain, propagation path, received power, like that, a different antenna pattern. You can load and plot, or you can directly plot the characteristics. So delay spread with with this select the axis, the C power or with the distance, you can plot it. Because I did not define the structure properly due to the time limitation, so there may not be the accurate graph. But definitely these all are plots you can plot. Let me load and then plot it. Per minute. So the same graph will be visualized in that, but I have not defined all the uh, all the summary in this tutorial. That's why properly we may not be able to describe. But these ray graphs you can easily obtain using this wireless inside. So since we have some limitations of time, and I need to explain MIMO version as well. So fully, I did not follow that tutorial, and that's why I'm not able to visualize in that properly, and not able to simulate whole this tutorial. Now, for we need to conclude this session up to 12. Or one more document.
Hello.
Yes, ma'am. Tell me.
Huh.
So
We
my
can take
session is
your session is up to 12:45
okay.
for this particular massive memo, but this part is extended. So we'll just take 2 minute break and we'll start again. You can
Fine.
take 2 minute break, then we can start
Fine.
again.
So audience, you can please type your questions in the chat box if you have. And after 2 minutes, we will go for the MIMO with the massive MIMO applications. I will prove an example of MIMO and massive MIMO application in this 30-minute sessions. The indoor propagation videos and MIMO and massive MIMO reference examples. So now let me go to the MIMO tutorial. Example, but you can create by yourself. Click on the load image file, project, open, and click on image. In this image, there is a format called this TIFF format. I open this file. Now this it is imported here. 1 minute. It is importing. Now we need to image property. We need to define the top left corner and top right corner. because we have imported that image file. I check this coordinate system to the Cartesian. Top left corner x equal to 2.75 and the value of tutorial I am performing from this tutorial. Now I click on OK. Now you can see this is a city which you can visualize. You can see there are a lot of buildings are there. By different visualization, you can do different direction. You can visualize that. Now, after importing this image file of city and terrain, you need to load a city. This is the image only, but we need to load the city. So click on Open Project, Open Features and City. Now I'm importing the city file, Roslyn is city in USA. I'm importing this so that you can visualize your structure properly. Click on Open. Now we can visualize that city building. And 3D rendering window, you can see how this city can be imported for this wireless propagation. So terrain image file is imported and city is imported. There are a lot of buildings are there and each building is having different heights. And you can assign the each materials of the buildings and change the material property. Now we need to define the material is already assigned, concrete material with this wave frequency. With the city material is already assigned, or we can also assign. Now we need to create the waveform. Go to this waveform view and create this waveform. Use sinusoidal waveform of 28 gigahertz bandwidth. And you can also enter the carrier frequency and effective bandwidth. The carrier frequency will be equal to 28,000 or something. And effective bandwidth equal to 10 megahertz. And then click on OK. Now we need to create a MIMO antenna. Click on Antenna tab. Create a dual polarized 4x4 MIMO antenna array for the transmitter. I click on new project antenna. In this antenna, we can find the choose MIMO antenna here. This is MIMO antenna. I click on MIMO antenna and click OK. Now this is MIMO antenna property where waveform is associated 28 gigahertz waveform. Now here we need to specify the MIMO antenna properties window. So this is MIMO 4x4. You can also specify 8x8 MIMO antenna dual polarized. And now you can add new antenna. Right click, add new antenna. In the add new antenna, you can select half wave dipole and click OK. Now leave the wave dipole property as it is and click OK. Now we need to click on build element array. So this is a memo array builder. In this memo array builder, we can select half wave dipole from the top menu. And select the wavelength radio button. This button. Wavelength equal to lambda equal to this value. So we can specify one x equal to 1, x element x and x spacing equal to 1 cross 1, y element equal to 4, spacing equal to 1, and z element equal to 4 and spacing equal to 1. Now click OK. This half wave dipole antenna array is adding. Now you can see, summarize this. This is 4 cross 4 antenna array. And you can see its in antenna and position and rotations. You can visualize this angle. Position of antenna, wave dipole 4 cross 4. This is memo array builder basically. Now click the build element array button. Begin adding another antenna. Default settings with previous one. Now we have added two element array. You can see. They are 4 cross 4, 16 and 4 cross 4, 16. Now click OK to the memo array builder. Now this memo antenna is added. You can also import the memo antenna from other software like XFDTD software from this RAM-COM. So directly you can also import this MIMO antenna from other third-party software. Okay. Now you need to define the transmitter and receivers. So in the transmitter and receivers, you can create the transmitters in the point shape. And you can specify the location. Automatically it will reach that particular location. You can define that in this window. So these windows are coming automatically once you click in the graphical user interface. This is a Cartesian system coordinates where x and y value we can specify. This is MIMO antenna. And you can also specify the input power and rotation in the Z axis like that. You can click OK and apply. Like this is a transmitter set. In the point form we have applied here. Now we can also create the receiver routes. A receiver and receiver routes. And we can specify the location of receiver routes like that. These routes we can specify. And receiver set properties. That is already set it. Waveform is already there. Click OK, apply, and then click OK. Now this is receiver routes. Different color, basically due to the color we cannot visualize properly. But this is root receiver route. Okay. Now we need to go to the study area where we can define the propagation models. So this is study area. Click new and go to study area, with two features and begin. And here we can enter the study area properties like MIMO base station and X3D propagation model we can use, and the default things we can use. We can use this APG neighbors method, acceleration properties like that. Now click OK to finish this point. Now we can run the calculations. One example is already there, which I can show you that example. Say X3D propagation calculation log window, which is starting the calculation. Now by viewing the output of MIMO, you can click on the output tab. Channel data for MIMO analysis. Export to file. But let me open one example for this MIMO, massive MIMO application. So this is like whatever we have done till now, you can see here. So this is city. Here transmitter and receiver routes are there. Hello, yes ma'am, tell me.
Yeah, now it's okay. Otherwise, in between
So can I continue?
there was continue.
Okay, fine. So now these things we have imported the terrains, cities, define the waveform, transmitter, receivers, study area, MIMO antenna, MIMO array builders, 4x4, two MIMO array we have defined. Now in this basically you can see the image imported, features, materials, waveforms, sinusoidal waveform associated, antenna. In this example, 8 cross 8 dual polarized dipole antenna is used.
So,
And the transmitter and
yeah. in this system, how many antennas are supported to simulate?
Limitation is not there, but
Yeah.
it depends on your hardware.
System configuration basically.
Yeah, it depends on system configuration, but you can define 16 cross 16 array of antenna as well.
Okay.
So limitation is not there. Only a hardware limitation depends how much your
Okay.
system is good. Yeah. So if you're having GPU in your system, then definitely you can simulate many number of antenna array.
Okay.
So this is a study area where X3D propagation model is single input, single output, and multiple input, multiple output. And these are some output. Let me show it to you. In this output tab, point to multi-point, channel data to MIMO, and base station, and mobile data. I right click, click on browse result. So this is MIMO output browser. This is output browser. Either you can export to the file, receive power, or you can view in the project. So either you can export, there is an option called export in the Excel format. Like this data is exported. This is data exported from the transmitter receiver side. If you want to view in the project form, this is a Excel file exported, the power, received power. If you want to see in the project view, there is an option called view. This is power received power visualization, where minus 40 dBm, minus 120 dBm. This color graph is showing the received power. Now, let me add more add plot to the graph. This is add plot to graph. Where you can see the output in the graphical form. The receive power with the receiver's point. So these are some you can see in the extraction form, like data can be extracted in the Excel format or in the graphical form or in this format. You can visualize this output MIMO, let's say MIMO output. So there are a lot of things in that you can, there is no such limitation of antenna. Any number of antenna or any shape of antenna you can specify. Any receiver routes, any number of receivers, lot of material library, and any building height. You can import that Google format inside the software. So massive MIMO with beam forming diversity. Now Ramcom is also extending its capability for IoT application. Wireless inside is also extending for IoT applications. And it is also going to be extended for 6G application for high frequency analysis in upcoming versions. Recently, IIT Delhi is purchased the software, 3 licenses permanent from Bharati School of Telecommunication, IIT Delhi. And last month we got the order. So these are basically indoor, outdoor, or MIMO application can be simulated. If more tutorial you want to perform, you can go to the reference manuals or user guide. I can upload these manuals on the Google Drive, and those who are interested, we can share these links with you. Let me show you some published papers by our Indian potential customers. One minute. So these are documents. All documents are there. 5G manuals, papers, and these are published papers. There are some DTU published. DTU also published some papers. SRM University, IIT Kharagpur, IIT Delhi, in Elizabeth Good Journal. Some latest papers is also there on channel modeling, millimeter wave, MIMO and massive MIMO, diffusion scattering with MIMO.
Um, Anilji, I would request you to please send these links to me
Yes,
so that I can see these papers and details, how they are using this particular software.
definitely. So I will share these links on your email ID. You can also forward to all the audience who are interested.
Yeah, yeah.
And
I'll,
from my side, I explain most of the features. If more information details are required, then interested customer can also contact me later on my contact details. So let me show my contact details again. You can note it down again and let me know whenever any interest. So thank you from my side. Thanks to Dr. Garima Seni. And I request to participant to type some questions for 5 minutes if they have.
yeah, I request all the participants to ask their query if they have any query from any of the participants regarding this particular technology part, outdoor indoor propagation and massive MIMO. Sorry, somebody is asking about wireless site suite software.
Yes, may I know what is the question?
They're just asking about wireless site suite software for demonstration, basically.
But I don't know about wireless sites you.
This particular software, actually, your slide is not visible, your screen is not visible, so you can give the detail of the software name and
Yes,
any
I
of
can.
the demonstration software for them.
Yes, I can share you the link. You can just share it with all the participants.
Yeah. So could you provide demonstration software also, link also, so that if anybody interested, they can do some work and then after that they will see the capabilities
Yes.
because in later it's not possible for them to see each and everything.
Mhm. So yeah, there is a possibility of 1 month trial license. Those who want to explore the capability of the software, and it is we can provide 1 month license really, and they can explore and understand the capability. And
Oh,
if any plan, then they need to be purchased because the license these are the commercial software. After 1 month, if
okay.
you're interested, in future they can plan to purchase.
Yeah. So is there any query from any of the participant? Um, yeah, one participant is asking, he is doing his PhD on spatial modulation technique for MIMO system. uh, Want to ask how to start the work and where I can analyze the performance of system. Spatial modulation technique for MIMO system.
Basic modulation techniques for my MIMO systems, right?
Spatial
Yeah, it will
modulation technique.
which modulation techniques?
I'll just retype this question to you.
Okay. So Mr. Jeetu Babu is asking how it is different from HFSS. HFSS is basically for antenna simulations, but not for that 5G massive MIMO wireless propagation. It cannot be used. That is for antenna simulation. Special modulation techniques for MIMO system. I want to know how to start working where I can analyze the performance. So, Mr. Dr. Santosh Kumar, you can contact me later on. I can share you some my experience on that and how it can be beneficial for a special modulation technique for a FSK, QPSK kind of application. I can share some brochure or some thesis which you can read and understand that how you can start work and analyze for special modulations specifically. So cost of this software is basically, let me give you, cost is around 6 to 7 lakhs for single permanent license. Single permanent license will cost around single 6 to 7 lakhs. So I'm writing my mobile number, those who are asking in the chat box.
I think is the query from any of the participants. Sir has already given his mobile number.
Yes, I have
And
already entered in the chat box my mobile number and email ID.
so you people can contact him on this mobile number and email ID if interested in this technology or software. One who they are. I think there is no other query from any of the participants. So I would
So
like to thank. Are you receiving
I
any
would
query,
like to
Mr.?
definitely. So later on, they can also contact me. And I would like to thank Dr. Garma Shani and all the participants. Thank you once again
Yeah.
from my side.
Thank you, Mr. Anil. Thank you for giving your time and giving exposure to this particular software regarding 5G, massive MIMO, and indoor-outdoor propagation models. Thank you.
Thanks a lot. Thanks a lot, man. Thanks.
Um, you can leave, sir, no problem. So I would now we will continue with our valediction session. Yes, we have completed our 2 sessions for the day. Now we would move towards our valediction session. So if anybody who want to say anything about this particular sessions or the course, they can write in chat box. So from Nitra Chandigarh, I would like to thank all of you for completing this course successfully. And I hope this course has given you information related to your topics or areas of interest. You want to do work in which area related to wireless communication basically. So I hope this particular STC has given something to you, and I'm thankful to all of you. As per the assignments queries, I have downloaded all the responses and I have received maximum responses. So approximately, because you have submitted 2 times, 3 times, I have received approximately 215 to 20 responses from single assignment. And I have checked the email IDs compared with your particular confirmed email IDs. So I have received, many of you have asked me from yesterday also, today also, and day before yesterday also. So I have mapped your emails with these responses. So I have received your assignments. Today I will post one assignment, simple 5 questions, just 5 questions assignment, and the link and the PPT provided by the Anil Sharma sir, I will post whenever he will provide it to me, whether today or tomorrow. I will post it in the particular session, Google Classroom. And for the certificate, it will take around 10 to 15 days because I have to map all the names and email IDs again. There are some email IDs which are not identifiable. I'm trying to identify them for which name it is. Otherwise, I have to ask you also itself that which ID is this and whose ID is this. So I know, I hope you will have patience and you will basically keep patience for the certificate because it will take time, and now the portal is very new to me also. So we are working on this portal first time, so we have to look for some loopholes also. We will get to know some loopholes also. Maybe some of the participants are receiving confirmed mails from that particular portal and their email IDs and names are not registered in our list, and still I think some of you are attending, so I can't say that you will get the certificate, but if you are attending, it's very I'm happy that you have attended this course, and hope you have also get something from this particular. Yeah, thank you so much for giving me such a nice feedback from you. And one of the participant, okay, Mr. Santosh Yadav, thank you so much for giving me such a nice feedback. And if any of you need any help regarding your research area, I can, whichever possible, I can help them. My research area interest is basically antenna designing and wireless communication. I have done my PhD in the area of antenna design using HFSS software. So I can help you in that if anybody required any type of help. Today's assignment last date, I will give it till tomorrow because I will post it after lunch and I'll give it to you till tomorrow. So till tomorrow you can submit your assignment. And I request you all, please submit all your assignments and attendance part for the first day. I have mentioned some attendance slide point. So you just post all your assignments and these till tomorrow. Don't get feel it panic. Someone is asking about the link of the assignment. Any of the assignment, Madam Deepa Rani, you are not getting any of the assignment or the Google Classroom link. You have not received Google Classroom link. So, any other participant who want to say anything? But I'm repeating again. Please be patient for the certificates because I have to process. And the one who are receiving the assignments are due. I have received the assignment from you people, assignment 1, 2, and 3, because I have mapped your email IDs. The one who have submitted, I have mapped those email IDs. So Sanjay sir, your assignment is also there. I have seen all the 3 assignments by your name, and I'm happy to see your assignments. Yeah, you are basically need to fill the feedback form submitted uh, over here in the chat box. This may be these assignment due responses you are getting maybe due to some other problem because I have explored each and everything. There is no other issue, but I have received your assignments. So don't worry about your assignments if you are getting the due message. And please fill that feedback form. The link is given in the chat box. The Sneha has shared that link. Thank you so much, Ji Uma Shankar. And obviously, as people are asking about another courses, if you have time, you can see next week also we have some course related to IoT implementation by Dr. Balwinder Singh Dhaliwal, and it is industry supported course, hardware and software related part. So you can go. It is basically paid course or having a fee of I think 500 rupees. So you people can go on the website and see the course by Dr. Balwinder Singh Dhaliwal, IoT and Embedded System. So thank you so much, all of you, for the support you have given to me and Neha also for this course, and that is why we have conducted this course successfully. And I would like to thank Neha also for giving me technical support, and I was very free from technical side that Neha is there to handle so many problems. Thank you so much, Neha.
Thank you, ma'am.
Thank you. So with this, we are going to off and we will meet again in some other course. Thank you all. Thank you so much.